Good morning. Today we're going to continue the radical class that we picked up last before the break. This is part two of roots and radical expressions. We are in chapter 6. We're still on lesson 1 just because the concept it's a little bit difficult to grasp. But nonetheless, we are going to continue on with the class. Today we're going to complicate it, but it's not going to be all that difficult. At the end, you need to understand that corresponding to every power, there is a root. Remember, the power is the key and the root is the jail, all right? We talked about 5 to the power of 2, which is equal to 25. But if you do the square root of 25, you are going to obtain 5. So that's the correlation in between the power and the root. And at the end of the class, you should be able to get a good grasp of what that means. Okay, let's get started. All right. So this is the continuation of chapter 6, lesson 1. Okay, we are going to continue talking about roots and radical expressions. And just to refresh your memory a little bit, this here is the sign for radical. But we're gonna call this the jail. Okay? And there is a number in here. We call that number index. Okay? But for the effects of comprehension, we're going to call this the lock of the jail. Okay? And the number inside, it's called the radicand. The radicand. Okay? But this here we call the prisoner. Okay, and that's the game we play. We need to get this 25 out of the jail, okay? But if you analyze 25, when you do primal factorization or prime factorization, you are going to notice that 5 times 5 it's equal to 25, and 5 are prime numbers. Therefore, 25 is it's equal to times 2 times 5, right? And 2 times 5, it's also equals to 5 to the power of 2. And therefore, if we now rewrite this the square root of 25, and instead of 25, we put 5 to the power of 2, we are going to realize that the power and the root are the same. And therefore, number 5 gets to be out of jail. Okay? So this guy's out of jail, therefore we're not going to write the jail no more because it's free. And therefore the answer is 5. Okay? And that was the basic concept that we learned before we started talking about roots and radical expression. Now, today we're gonna complicate the topic just a little bit, okay? because we're now going to incorporate variables, okay? So now we're going to incorporate variables, all right? If you have an exercise, this is an example, okay? So if you got 16x to the power of 8, and they're asking you to get the square root of that. Okay. The square root of 16x to the power of 8. You have to remember that when the square root does not have an index, automatically you gotta put a 2. Okay? It's just as when we have a variable, it doesn't have an index, but automatically you put a 1 in there, right? We just don't see it. The same case is in here in the roots. If you don't see a number, then you put a 2 in there. That means that your prisoners, they gotta have the right key, and the right key has to be a 2. So you are going to take these two terms, or the variable and the number, and you are going to separate them. You're first gonna take the 16 and you are going to do prime factorization on the 16. Okay? And if you're not too good with factorization, you can always use a calculator. If it is a paired number, you can divide by 2, and therefore you got 2 times 8. It's equal to 16, right? Number 2, it's prime, so we don't have to do anything else with the 2, and now we gotta split the 8. So 2 times 4 is equal to 8, and 2, again, it's prime, and then 2 times 2, it's equal to 4, and there you have it. So this here is equal to 2 times 2 times 2 and times 2. But you need a 2 as an exponent to get out of the jail, to get the 16 out of the jail. And all these guys, they all have a 1. But if you combine them in 2, then you'll have the right key to get out. Therefore, you can turn these two, it's equal to 2 to the power of 2. And these two are also equals to 2 to the power of 2. So this is equals to 2 to the power of 2 times 2 to the power of 2. Okay? Now you got to take the x. Letters are easier to deal with than numbers. 8 to the power of 8, or x, I should say, to the power of 8. All right. If you need a 2, you gotta see how many 2's you can fit in an 8. Okay. So watch. 8 divided by 2, it's equals to 4. Okay? So watch this. X to the power of 8, it's equal, and remember you need 2, okay? You need to have 2 as an exponent. So you're gonna put 4 x to the power of 2 times x to the power of 2 times x to the power of 2 times x to the power of 2. And watch, 2 plus 2 is 4, plus 2 is 6, plus 2 is 8. Okay? So now that you have these numbers with the right exponent, you know that this 2 gets out of jail because it has the right exponent. Okay, let's do the right representation so that you understand. If you put 2 to the power of 2 times 2 to the power of 2, and remember this is the second root or to the square, right? So you know that all these guys, they get out of jail, all right? And therefore, this becomes 2 times 2 equals 4, okay? So the 4 gets out of jail, okay? Now you got to do the same with these guys. The square root, remember there's a 2 here. X to the power of 2 times x to the power of 2 times x to the power of 2 times x to the power of 2. Okay. So all these guys have the right key, so all these guys get to go out of jail. So this here is equals to x times x times x times x. Okay? So that is equals to 4. Oh, I'm sorry. X to the power of 4. Okay, because all these guys, they all have a 1, right? So 1 plus 1, 2 plus 1, 3 plus 1, 4. So x to the power of 4. And the x to the power of 4 gets out of jail. And then this here, it's the answer. Okay? All right, we'll do a more complex example. Okay? So you got the cubic root of a to the power of 6 and b to the power of 9. You're gonna need an exponent of 3 on these guys to get them off jail. So you are going to take them apart and you're gonna try to put them all in terms of the exponent of 2. Watch. Take this exponent for instance. 6 divided by 3, because you need a 3, okay? That is equals to 2. Therefore, this a to the power of 6 could be rewritten this way. A to the power of 3 times a to the power of 3. 2 times a to the power of 3, right? Because you need a 3. And 3 plus 3 equals 6. So, if you rewrite this, well, let's not get there just quite yet. Let us deal with B after we deal with A. So, watch this. Let's do this in a separate part. Okay, watch this. If you take these guys and you put them all in jail, like this one is right now, you're gonna notice that the A's are gonna get out of jail. And therefore, this is A times A, and that is equal to a to the power of 2, because you got this 1a and this 1a. 1 plus 1 equals 2. Okay? Now you got to deal with the b to the power of 9. Okay? B to the power of 9. Watch. So you take the exponent that you want to break up, and then you divide it by the number that you need, and that's going to give you 3. So you're going to need 3 terms. All right? And therefore, the cubic root of b to the power of 9, it's equal to the cubic root of b to the power of 3 times b to the power of 3. And again, the b's are going to get out of jail, and that is b times b, and these have exponents of 1, and when you add them together, you get b to the power of 2. And therefore the answer to this, let me see if I can move this along, because I want it to be clear with the answer. Okay. So the answer to this, it's the combination of this number times that number. So this is equals to a to the power of 2, b to the power of 2, and then you are done. Okay? All right, let's do another example, a little bit more complicated. Okay, now you got the 4th root of x to the power of 8 times y to the power of 12. Okay, so now you're gonna take your first, I'm gonna go a little faster on this one. Okay, you're gonna take the first term and you are going to convert it into x to the power of 4, right? Times x to the power of 4, okay? Like so. All right, so these two guys are gonna get out of jail. Therefore, this is equal to x times x, and this has exponent of 1. So 1 plus 1 equals 2. Okay? So that's your first result, so to speak. Okay? And now you're going to take the next subject to the power of 12, all right? The 4th root of y to the power of 12, okay? Now this one, it's going to yield 12 divided by 4, it's 3. So we are going to get y to the power of 4 times y to the 3 times, right? Because 12 divided by 4 is 3, right? Like so. Again, everything that has a 4 for a power, it's going to go out of jail. So that's y times y times y, okay? and that is equal to y to the power of 3. Okay, and what's left to do is to combine these two guys. Okay, to combine these two guys, okay, and put them as an answer. So x to the power of 2 times y to the power of 3, and then that's your answer. Okay? Alright, so let's talk about your classwork for today. At this point, you should have been given this paper, which corresponds to the second part of radicals or simplifying radicals. So let me pick a few of these. You got to do from 1 to 18, okay? You got to do from 1 to 18, all right? So we're gonna do, actually no, you're gonna do from 7 to 18. So make sure that take note of this, because the first part you already did. Okay, so you gotta do this part, okay? From 7 to 18. Let me write it up in here. Exercises from 7 to 18. Okay? That's 12 exercises. All right? So I'm gonna pick the hardest one that I think it is, which is maybe 14. Okay? All right, so this here is the cubic root of this whole thing. All right? So we are going to take them one at a time. So you got 16, all right? And 16 can be split into 2 times 8, all right? And one of these have to be negative, all right? And then, so let's put the 8 negative, all right? Let me make sure I put it right. So the 8, it's negative, and the 2, it's prime, okay? And then when you split the 8, okay, you are going to have 2 times negative 4, okay? So one of these guys is negative. And then 2 times negative 2, okay? All right, so you got the result, obviously it's going to be negative, okay? So you got 1, 2, 3, 4 2s, all right? You got 4 2s, all right? So it's negative 2 times 2 times 2 times 2, okay? And you need a 3 to get out of jail, all right? So, I gotta change colors here because I'm going to this side. Okay, so if you need 3 of them, right? That means these guys can be grouped together. Now this one unfortunately gets to stay in jail, right? So this is equal to minus 2 times 2 to the power of 3, okay? Now remember that the 16, we're trying to get the 16 out of jail, right? So negative 2 times 2 to the power of 3, they're all in jail, right? And the jail has a key which represents a 3. Therefore, only 1, 2 gets to go out of jail, okay? So that is equal to this 2 that went out of jail, and then unfortunately the negative 2 stayed in jail, right? Okay, so now we are going to take the A. Now we're going to take the A to the power of 3. And remember, A, it's in jail, okay? All right, so this one's easy, right? Because he's got the right key. Therefore, A gets to be out of jail, all right? Now you got to do the same with B. Again, B to the power of 8 is in jail, all right? And now you got an odd number here, right? So watch this. How many times 3 fits in 8? Only 2, right? Only 2. And watch this. 8 divided by 3, it's equal to 2.6. So that means one of them, a couple of B's are gonna stay in jail, all right? Okay, so this here, it's equal to the cubic root of B to the power of 3 times B to the power of 3, right? 3 plus 3, it's 6. How many exponents are left? 2, all right? So I gotta put B to the power of 2, all right? So this B gets out of jail because he has the right key. This B gets out of jail because he has the right key. B to the power of 2, however, has to stay behind. So you got one B that get out of jail, which is this one. And then you got another B that gets out of jail, which is that one. And B to the power of 2 stayed in jail. Now, these two you can combine into one, right? Because you can say that this equals to B to the power of 2. And that's exactly what we're gonna do to finish the exercise, okay? So you got B to the power of 2, and then B to the power of 2 that stayed in jail, okay? All right, so now that you have all these components, all you have to do is just to combine all these guys. Combine them together. Okay? So, at the end, the answer to this exercise, it's going to be equal to 2 the square root of minus 2, and then A, right, times A times B to the power of 2 and the square root of B to the power of 2. And listen to me, everything that's out of the jail, you gotta put together, okay? Okay, watch. Let me go ahead and put this result in here. Remember, we're combining this with that and with that, okay? So you got 2 times the square root of 2 times A times B to the power of 2 and the square root of B to the power of 2. Okay? This is the cubic root. I'm sorry. The cubic root. okay? Yes, all of these are cubics, okay? All right. So all that's there is left to do is that you gotta combine these two with this A with this B to the power of 2 and put them on front. So that's 2AB to the power of 2. And then you're gonna put everything that's in jail together. So you gotta put this 2, -2, and that's B to the power of 2. You put them inside. And there you have it, folks. This here is the answer to this exercise. Okay? I'm gonna go ahead and do one more. We'll do a simpler one. Let's do number 9. We'll do it. We will do it number 9 over this side of the board, so we'll have space. Okay. So this is the 5th root of 224 r to the power of 7. And this is number 9, okay? Like so. Let me go ahead and move it so that we can have space to elaborate. Okay. All right, so this is exercise number 9, right? We're gonna do it really quick for you. Now you gotta remember you need a 5 to get out of jail, all right? So you're gonna break these two apart. First, we are going to deal with the 224, the 5th root of that, okay? Now when you do prime factorization, 224 divided by 2 equals 112. 2 its prime, 112. Divide that by 2, that's 56. And remember, if it's a paired number, you divide by 2. If it ends in 3, most likely it's gonna be a multiple of 3. If it ends in 5, most likely it's gonna be a multiple of 5, and so forth, okay? So this is 2 times 56, okay? And 2, it's prime. And then again, I'm gonna divide by 2, okay? So 56 divided by 2 equals 28. Okay, and again I'm gonna divide by 2 and that is 14. Okay, and again I'm gonna divide by 2. 14 by 2, and that is 7. Okay, and 7 is prime and 2 is prime. Okay, so 224, the 5th root of that, it's equal to the 5th root of 2 times 2 times 2 times 2 times 2 times 7. okay? Because this is equals to exactly that, all right? Okay? But you can combine all these guys onto 2 to the power of 5 times 7. So all of this is equals to the fifth root of 2 to the power of 5 times 7. 5 gets out of jail, and therefore it's 2 times the fifth root of 7. Now you got the first number. Now you got to deal with the r, okay? Now you got to deal with the r. And the r, it's to the power of 7. So the fifth root of r to the power of 7, okay? Look, 7 minus 5 is equal to 2. So you're going to have a r to the power of 2 stuck in there somewhere, okay? So this here is equal to the fifth root of r to the power of 5 times r to the power of 2. You're probably thinking, where did he get that r to the power of 5? Because this is the trick. You take the number inside, which is that one, and you subtract that to the number outside, okay? And whatever's left over, it's what's gonna stay in the jail, okay? So that is equal to, look, r to the power of 5 gets out of jail, and therefore you get r times the fifth root of r to the power of 2 that stay in jail. And that's the other number, okay? So now that you have these two numbers, all you have to do is combine them, right? All you have to do is combine them. So you take these two numbers, you combine them, and when you combine them, it's 2 times the fifth root of 7 times r to the power of 5 and the fifth root of r to the power of 2. You are going to take what's outside, okay? You're gonna take what's outside and you're gonna combine them together, and you put them in the front. So this is 2r to the power of 5. And then you are going to take what's inside, okay, and you're gonna combine them together, and you're gonna put them in jail. So this stays in the jail of the fifth root, right? 7r to the power of 2, and that's the answer to this exercise, okay? So there you have it, folks. You have to do 12 exercises. I gave you number 9 and I gave you number 14, which 14 I thought it was the hardest one, but they're all good, understandable levels, okay? If you have a question about any part of the lesson, raise your hand. Talk to your proctor. He can pause the video or he can replay it again if you feel like you need to hear it again. But make sure you do your classwork, okay? We'll see you when I get back. I hope you have a wonderful, wonderful day.